Okay, in this video we're going to look at factoring the sum or difference of cubes. In math, sum means addition and difference means subtraction. These will be binomials, which means they will have two terms, and they can be addition or subtraction, and the two terms both have to be perfect cubes. So first I want to talk about what a perfect cube is. So perfect cubes are numbers that you get or terms that you get when you cube a number or a variable. So we'll start with numbers. When you cube the number 1 or raise that number 1 to the third power, you're going to get 1. So 1 is a perfect cube. When you cube the number 2, you're going to get 8. 2 times 2 times 2 is 8. So 8 is a perfect cube. All right, the next perfect cube will be 27. That comes from 3 times 3 times 3. I'll keep going. We're going to have 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. Think about 5 times 5 is 25, and then 25 times 5. 25 is like a quarter, and if you have 5 quarters, you have $1.25. So 5 cubed is 125. And they get big rather quickly. I'm going to go ahead and list up to 10. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729, and 10 cubed is 1,000. I think that'll give us plenty to work with at this point. Now we can also have some variable terms that are perfect cubes. If we multiply x times x times x, that gives us x cubed. So x cubed is a perfect cube. If we multiply x squared times x squared times x squared, remember when we multiply we add our exponents, so that would be x to the 6th. That's a perfect cube. If we multiply x cubed times x cubed times x cubed, 3 plus 3 plus 3 would be x to the 9th. That's a perfect cube. The next one would be x to the 12th. And if you look, you can see a pattern here. 3, 6, 9, 12. They're multiples of 3. So any variable raised to a number that is a multiple of 3 is going to be a perfect cube. So that could keep going. And it doesn't have to be x. It can be a or b or m or any variable. All right, so we'll start with one like this. Okay, this is the sum of cubes. X cubed is a perfect cube. We saw that here. 8's a perfect cube. We saw that here. It's being added, so this particular one is the sum of cubes. Okay, the good news is we factor the sum of cubes and the difference of cubes almost exactly the same. So once we learn the method, we won't have to learn a different method for difference. All right, so when I factor a sum or difference of cubes, I always say we have a small parentheses and a big parentheses. And what I mean by that is in this first parentheses, we're going to have a binomial. We're going to have 2 terms. In the second set of parentheses, we're going to have 3 terms, a trinomial. All right, so I'm going to go over with you how to fill in these blanks here, what we're doing. So in this first blank, we're going to say, what is the cube root of x cubed? Well, the cube root is basically the opposite of cubing something. So we're asking, what did we multiply times itself 3 times to get x cubed? And that would be x. You can see that we did it right here. So that's what's going to go here. The cube root of 8 is asking what number cubed will give us 8. And we see right here that it was 2. So that's how we fill in these first 2 blanks, okay, by taking the cube root of each of those numbers. Now I'm going to call what's in this first blank number 1, and I'm going to call what's in this second blank number 2, because those will change from problem to problem, but I'm going to write down what to do to those terms to fill in these 3 blanks. So in this first term, we're going to fill in this blank by squaring number 1. All right, so number 1 is x, and if we square that, we get x squared. Okay, to fill in this second blank, I'm going to multiply number 1 and number 2 together. All right, so number 1 is x, number 2 is 2. So if I multiply x and 2 together, I get 2x. And to fill in my last blank, I'm going to square number 2. All right, so look at number 2 is 2. If I square 2, I get 4. Now I want you to notice I didn't fill in any signs as I went. I just filled in the blanks, and I've got to go back and I've got to put signs in here, and I'm going to show you how to do that. So I use this little SOAP to help me remember how to put my signs in. So SOAP stands for same, opposite, that's the O, and then AP is always positive. So once you've got all your terms filled in, then you want to come back and fill in your signs using SOAP. So same means same as in the problem. So that's first one's going to be a plus. Opposite means opposite of what's in the problem. So that's going to be a minus. And then the last one is always positive. Okay, so we've got it factored. That was the sum of cubes. Let's do another one, and let's do difference of cubes. Okay, I'm going to show you that it's almost exactly the same. The only difference will be the signs will be different, but you still use SOAP to fill the signs in correctly, and it will work. All right, so we see that we have a perfect cube here, and we have a perfect cube here. We've got it over here on our list, and it's subtraction. So this is the difference of cubes. I'm going to have one short parentheses and one long parentheses. This one's going to have 2 terms in it. This is going to have 3. All right, so to fill in those first 2 terms, I'm going to take the cube root of both of these numbers in the problem, or both of these terms in the problem. The cube root of x cubed is x. We see it right here. The cube root of I said the answer. The cube root of 343 is 7, because you're asking what number raised to the 3rd power, or what letter raised to the 3rd power would give you this. So this is going to be x, and this is going to be 7. Then to fill in this first blank, we're going to square this first term. So that's going to be x squared. To fill in the middle blank, we're going to multiply these 2 together. That's going to be 7x. And to fill in the last blank, we're going to square the second term. So that's going to be 49. All right, then we're going to get back and fill in our signs using SOAP. This is same as in the problem, so it's a minus. Opposite of what's in the problem, so that's a plus, and the last one's always positive. Okay, so that is showing you how to do the sum of cubes and difference of cubes, and you see you do them exactly the same. You even still use SOAP to fill in the signs, but you'll see the signs will be different on this one than they were on this one, so it all works itself out if you follow these steps and you use this little SOAP acronym. All right, let's try another one. All right, let's see. We have 5x cubed minus 40. All right. So I don't want you to forget that on any factoring problem, the first thing you should look for is a greatest common factor. And this does, in fact, have a greatest common factor of 5. So I'm going to go ahead and factor out of 5, which will leave me with x cubed minus 8. Once I've factored out that 5, now I have the difference of cubes. This is a perfect cube, 8 is a perfect cube, it's subtraction. So I've got the 5. That is going to be part of my answer. Then I'm going to have the short parentheses and the long parentheses to fill in to factor this difference of cubes. So the cube root of x cubed is x. The cube root of 8 is 2. All right, then I'm going to come back and I'm going to square this first term. That'll be x squared. I'm going to multiply these two terms together. That'll be 2x. And I'm going to square this last term. That'll be 4. I'm going to fill in my signs using SOAP. Same as in the problem, opposite of in the problem, always positive. So this whole thing is my answer here, the 5 included, because all of that would multiply back together to give us what we started with, 5x cubed minus 40. All right, let's look at this one. Okay, so there's a lot more going on in this particular problem, but as long as everything is a perfect cube in the problem, then this can be the sum of cubes. So we check every part. 27 is a perfect cube because it's 3 times 3 times 3. P cubed is a perfect cube. 1000 is a perfect cube. Q cubed is a perfect cube. So we're good. We're going to have the short parentheses. I'm making it a little bigger because we've got P's and Q's in there. But we've got 2 terms and 3 terms just like before. All right, we want to do the cube root of the first term. And you have to make sure you do both parts, the number part and the variable part. The cube root of 27 is 3. The cube root of P cubed is P. Okay, so 3P. The cube root of 1000 is 10. The cube root of Q cubed is Q. So 10Q. All right, so once we have those two filled in, we use those to help us fill in this other set of parentheses. We're going to square the first term. When we square it, we have to make sure we square both parts. 3 squared is 9. P squared is P squared. Okay, so that's 3P times 3P will give us 9P squared. To fill in this middle term, we have to multiply these two together. 3P times 10Q is 30PQ. All right, and to fill in this last blank, we have to square the second term, 10Q. So we got to square both parts, square the 10 and square the Q. So we've got 100Q squared. And then we go back and we fill in our signs, same as in the problem, opposite of what's in the problem, always positive. And that will be the answer for that one. All right, let's see. I'm going to do one more. Let's see. Let's do this one. 4b cubed plus 108. Okay. When we first look at that, we might see this cubed and think it's sum of cubes, but 108 is not a perfect cube. See how it's not on our list? 4 is actually not a perfect cube. And hopefully that reminds us that the very first thing we're always supposed to do is look for a greatest common factor. And so 4 will in fact go into both of these. So I'm going to factor out of 4. So how many times will 4 go into 108? Well, I'm going to use a little mental math. I'm going to break 108 down into 100 plus 8 and divide each of those by 4. I know there's 4 quarters in $1, so 4 goes into 125 times, and 4 goes into 8 2 times. So the answer would be 27. So b cubed plus 27. Now 27 is a perfect cube, so now we have the sum of cubes. So I'm going to break that down into a short parentheses and a long parentheses, just like I've been doing. I'm going to take the cube root of b cubed, that's b. I'm going to take the cube root of 27, that's 3. I'm going to square the b and put that here, b squared. Multiply the two terms together, that's 3b, and square the 3, that's 9. Then fill in my signs with soap. Same as in the problem, opposite of in the problem, always positive. Okay, let's see. All right, I want to look at 2 more problems, one with fractions in it. I don't want you to panic. Oh, I really didn't need parentheses there. That's okay though. I'll just put one on this side too. Okay, so this is also the sum of cubes, as long as every part of every fraction, every part of each term is a perfect cube. And so we can go through and we can check. 1 is a perfect cube, 1,000 is, r cubed is, 8 is, 27 is, and even w to the 6th, because we saw up here that any variable raised to a multiple of 3 is a perfect cube. Okay, so we're good on cubes, so we know this will factor. We're going to do a short parentheses and a long parentheses. All right, so when we go to take cube roots of fractions, just do it in parts. The cube root of 1 is 1. The cube root of 1,000 is 10. And the cube root of r cubed is r. Okay, so I just did each part individually. Same thing here. Cube root of 8 is 2. Cube root of 27 is 3. And the cube root of w to the 6th is w squared. All right, now we've got both of our terms filled in here. And now we've got to use these 2 to fill in the rest. All right, the first blank here we will get by squaring 1/10 r. So when we square a fraction, we just square the top and square the bottom, and we'll also have to square this variable. So 1 squared is 1, 10 squared is 100, and r squared is r squared. So we'll get 1/100th r squared. To fill in the middle term, we're going to multiply these 2 together. So when we multiply fractions, we do top times top, bottom times bottom. That would be 2/30ths, okay? Now, 2/30ths will reduce. I'll just write it out here. We got 2/30ths. That will reduce if you divide the top and bottom by 2 to 1/15th. So we're going to get 1/15th rw squared, because we put those together. We're multiplying those together. And my last blank, I'm going to square this term. So I'm going to square the 2, square the 3, and square the w squared. When you square w squared, you get w to the 4th. Then I'm going to fill my signs in, same as in the problem, opposite of in the problem, always positive. Okay, it looks bad, but it's really not that bad when you go to work it. All right, my last problem. This one's kind of special. When you look at this problem, you may or may not notice, since we're talking about difference of cubes, you're probably on the lookout for difference of cubes. X to the 6th is in fact a perfect cube. 64 is also a perfect cube. However, this is also the difference of squares, which I have a video on that. If you haven't looked at difference of squares or don't know how to do difference of squares, you might want to go back to that video. But when you have a binomial that is both the difference of squares and the difference of cubes, you want to factor it as the difference of squares first. Okay, so I'm going to treat this as difference of squares first. Remember, when we do difference of squares, we do the square root of this first term, which would be x cubed. So these will both be x cubed. And we do the square root of 64, which is 8. And then it's always 1 plus and 1 minus. Okay? But if you'll notice, we are not finished, because now that we have factored this as the difference of squares, we are left with 2 factors. This one is the sum of cubes, and this one is the difference of cubes. So both of these can be factored further, All right, so each one of these is going to break up into a small parentheses and a big parentheses. That's for this first one. Then we'll have another small parentheses and another big parentheses. That's for the second. So let's look at x cubed plus 8 first. We've actually done that. It's up here. So we can do that again, filling in the cube root of x cubed is x, the cube root of 8 is 2. Square the first term, multiply those together, square the last term. Fill in your signs using SOAP, and for this one we're looking here. So same, opposite, always positive. All right, now we're going to do x cubed minus 8. Cube root of x cubed is x, cube root of 8 is 2. Square the x, multiply these two together, and square the 2. Fill in the signs with this one in mind. Same as in the problem, opposite of in the problem, always positive. So this one factored first as the difference of squares, and then you had to factor the sum of cubes and the difference of cubes. So this is your final answer here. All right.